wants to build a coal-powered plant, they can. It's just that it will bankrupt them because they're going to be charged a huge sum for all that greenhouse gas that's being emitted.
The majority of the world is made up of cold, lifeless rock. And in the tiny pores between these rocks lies a hidden treasure, unlimited reserves of natural gas.
Natural gas is considered the cleanest burning natural fuel resource, emitting the lowest amount of carbon dioxide of all fossil fuels, which include coal, oil, and natural gas. Composed mostly of methane, the main combustible products of natural gas are carbon dioxide and water vapor, the same compounds that we exhale. In contrast, coal and oil are comprised of more complex molecules, in association with a substantially higher carbon ratio, as well as greater nitrogen and sulfur contents. Not only has natural gas been regarded as a vital source of energy for reducing pollution, but it is also domestically viable. American geologists have known about the abundant presence of natural gas in shale for over 80 years. Hydraulic fracturing, commonly known as fracking, was pioneered in 1947. The process was used to stimulate the flow of natural gas to the surface. However, due to low permeability and poor flow rate, extraction was quite costly. By 2004, advancements in fracking technology led to the Marcellus Shale, the first major onshore well in Pennsylvania. With the energy revolution of American shale gas, mining industry drilling technology has led to global realization of the world's untapped energy potential. Over the past decade, the combined practice of hydraulic fracturing and horizontal drilling has unlocked shale deposits and brought large-scale global gas drilling. Initially, vertical hydraulic fracturing was the only way to reach shale, but was not cost-effective, mostly because very limited amounts of natural gas could be extracted. Horizontal drilling has allowed the drill bit to be steered along a horizontal trajectory, extending accessibility by many kilometers. Consequently, the well bore is exposed to a huge economically viable shale gas deposit. Ultimately, dependence on foreign countries for natural gas has been lessened. The hydraulic fracturing process begins once a well bore hole is drilled to a depth of anywhere between 6,000 and 10,000 feet until the shale deposit is reached. Next, steel casings are inserted into a depth of 1,000 to 3,000 feet, which coincides with groundwater levels. The prime concern is potential for groundwater contamination, so the space between the steel casing and drilled hole is filled with cement to stabilize the well and prevent leakage into the aquifer. After the cement has set, a series of successive steel casings are put into the well bore until the reservoir is reached. In the process of drilling, several thousand feet of solid rock are surpassed. Rock layers such as granite are dense and unaffected by fracking. This density acts as a barrier between the shale where fracking occurs and the groundwater, so seepage is prevented. Perforating tools and conductors are put in the borehole. The pipe is perforated, allowing fracking fluid, when injected into the well, to flow into the target zones. Once in place, the conductors emit shock waves into the shale, causing fractures or fissures. These tools are removed, and fracking fluid containing 3 to 5 million gallons of fresh water, sand, and proprietary chemicals is then injected. The fluid is 95% water, 4% sand or ceramic beads, and 1% chemical additives. The sand particles within the water is called proppants. At a certain point, the shale stops absorbing the fluid. The intense pressure causes the fissures to expand. Injection of fracking fluid is stopped and forced to flow back to the surface. This contaminated water is pumped into a surface reservoir tank, but proppants remain in the shale to hold fractures open. This readily allows the trapped natural gas to be extracted and flow to the surface, where it is collected, pumped into the reservoir tanks, and removed from the sites.